Welcome back to my channel. Today we are diving into an exciting JavaScript interview question designed for like intermediate developers. Okay. This problem tests your ability to think critically and work with the arrays in an efficient way. It's called find the smallest subarray to sort. Okay, and it's something you won't find in the internet. So stick around. So okay, let's see the problem statement here in the screen. Okay. So the problem states that we have to find the smallest subarray to sort. Okay. Your task is to find the smallest subarray, which when sorted makes the entire array sorted in ascending order. So let me show you one example. Okay. So let's say the input array is this. Okay. So that's 1, 3, 5, 4, 2, 6, 7. Okay. The smallest subarray that is the output is 3, 5, 4, 2. If I sort this part, okay, the entire array will be sorted. Okay. So that's the thing. The function should return an empty array if the array is already sorted, just like the below case. Okay. So yeah, so another problem is also like that this 4, 3, 2, 1 is already sorted, but it's in a descending order. So for that we need the smallest subarray, that is 4, 3, 2, 1. When we sort this one, the array will be sorted. Okay. And just another example, 1, 2, 6, 5, 4, 3, 7. Okay, so here from 6, 5, 4, 3, if we sort this, then the entire array is sorted. Okay, so we cannot use like the built-in functions. Obviously, we can use in a real interview, but if the interviewer asks not to use that, or in any other language they ask to solve this, then yes. Don't use the built-in functions for best practices. So, and we'll try to solve this in order of n. Okay. And okay, so let's start like how we are going to break the problem and we'll start code. Okay. So for starters, I already written the function name and all these cases where we can test. For now, if I just compile, it will obviously it will return on depend because there is nothing written from this one. Okay, so let me break this problem. Like let's first initialize. Okay, initialize. Then our step 1 will be find the left boundary. Okay, so what we are going to do, like we'll start with this 3 from the starting point of the array, where we'll see any out of order things like 1, then obviously 3 is greater than 1, then 5 is greater than 3, then 4 is not greater than 5. So our first index will be 2. Okay, and then we'll to find the right boundary, we'll start from the right, then 7, then 6 is less than 7, that is okay, but 2 is less than 6, that is also okay, but 4 is not less than 2. Okay, so our outer boundary is like at the 4. Okay, so now what we'll do, we'll find the then after that we'll sort this. Okay, like from the 5, 4, 2 we'll sort it, and then we'll check like everything is sorted or not. Else what we'll do, we'll again find the left boundary and right boundary. Okay, so let's initialize first. What we can initialize, the let's say the length of the array, so that we don't have to calculate it again and again. So I'll name equal to dot length. Okay, cool. Then we can start the left at 0. Then another right equal to we can say n minus 1. That's the last index. Okay, Okay, so next let's break the next step, like the find the left boundary, and then what we can do, find the right boundary. Yeah, if the array is sorted, that's one case. If the array is sorted, okay, then find the right boundary. Sorry. Then yeah, then min max of the subarray. So once the subarray is fixed, we have to find the min array. Okay, so that's step 3. Step 3 will be find and max of subarray. Okay, then expand the boundaries. Go step by step. Expand the boundaries. Okay, sorry. I spelled it. Okay, then yeah, return the final. So okay, so initialization already done. We don't have to do anything. Then let's find the left boundary. Okay, so a simple while loop will do. While left is less than the length n minus 1, obviously, and at the index, whatever the element is, the left, it should be less than equal to error left minus left plus 1. If that's the case, then left plus plus. So next is, if the array is already sorted, then if I will know that if left is equal to 1 minus 1, so if we have reached the end of the array, then yeah, return another array. So that's the condition we have. If it is sorted, then empty array. Next, let's find the right boundary. So for that, what we can do, while okay, the reverse case, and right is greater than 0, and this here array right should be greater than or equal to right minus. Okay, if that's the case, then we'll go right minus. Then we have to find the min and max of the subarray. Okay, so we can use math.min, or else we can create a function to find out min max. Okay, that's properly well known for the language as subarray min equal to on subarray max should be minus n. Now let's run a for loop. Okay. For loop where let I equal to left Start from there, then increment I is less than right. Plus. Okay, now let's just send sub array main equal to math dot main. Then we have to find out the current index and the current mean. Okay, so the sub array mean and the current index. Yeah, so let me copy this first. So here we're going to write max and it will be math.max subarray max. Okay. Yes, so yeah, that is it. Now expand the boundaries. Okay, so once it is done for the one subarray, and next we have to check again, like right now the array is sorted or not. So for that we'll expand the boundaries. I think now the conditions should be reversed. Okay, so they will now it's left to the right index. We will start with the 0 index. Okay. So again, why if the left is greater than 0 and left -1 should be greater than sub array left is should be the minimum, right? So it should be greater than the sub array minimum. Yeah, then left minus. Then another while for the right. So while right, it should -1 and array right +1. No, right +1, and it should be less than the max current max. So if that is the case, then we have to go like this. Okay. I think this should do. Yeah, we have to return this over. That's part. So now we have the indexes left and right. So return array dot slice. Okay. Then left and right +1. Yeah. So let me check. We are checking the index left boundary here and the right boundary here. Null sorted. And okay. Oh. Second step. This is the first step. Okay. Okay, let's test this out. I think I'm done. And let's check the time complexity here. Where only n. Here 1 for loop, that will also order of n. So yeah, forget the order of n. Let's run the program. Output effect.
Let's quickly discuss the performance of this solution. Okay, on the time complexity, you are scanning the array few times, once for the boundaries, once for the min and max, and possibly again to expand the bounds. So all this takes order of n. So yeah, it's order of n. Then in terms of space complexity, we are not using any extra spaces apart from a few variables, so it's order of one, efficient and clean. Okay. So that's it, guys. This problem is a fantastic way to test your understanding of array traversal, boundary conditions, and optimizations. So if you are preparing for interviews, make sure to practice problems like this. They are super common. If you find this helpful, don't forget to like, subscribe, and share it with your friends. Let me know in the comments if you would like to cover more such problems. Thanks for watching, and I'll see you in the next video.